Hello, everyone. Thank you for joining our webinar today. We're going to get started in just another minute. All right, we're going to go ahead and get started. So hello, everyone. Good morning, good afternoon, or good evening to you. Thank you for joining our webinar today on relational search, architecting the next generation analytics platform. This is sponsored today by ThoughtSpot. And just to introduce our speakers today, I am Andrew Young. I am on the product marketing team here at ThoughtSpot. Joining me here today is Vijay Ganesan, one of the co-founders here at ThoughtSpot, as well as the head of product management. And in the course of today's webinar, this is what we're going to be going through. I'm going to start off with just a brief overview of ThoughtSpot, kind of who we are and what our product does, and I will walk you through a product demo as well. And then after that, we'll really get into the guts of, how ThoughtSpot has actually built out this relational search engine and the underlying architecture. And after that, we'll walk you through kind of a simulation of kind of the life of a query within our entire platform. And then we'll end with some, key takeaways on how to get started, as well as Q&A. So, this is presented over BrightTalk, and so I do recommend that you do expand the screen to get kind of an optimal experience of the content that we're going to be sharing with you today. So with that, we're going to go ahead and get started. And if you have questions at all during the session, feel free to enter those questions in the questions panel. Vijay here, he will be monitoring those questions, and we'll be responding to those in real time as well. Obviously, we'll cover as many questions as we can towards the end as well. So, for those of you who are new to ThoughtSpot, here's really a quick overview of who we are. ThoughtSpot, we call ourselves the next generation search-driven analytics platform. And if we just kind of start here on the left-hand side of the screen, we started this company back in 2012. And our founding members came from the likes of Google, Yahoo, Amazon, and Oracle. In fact, 4 out of 7 of our co-founders actually came from Google. So, you can imagine the search, scale, and analytics DNA, that does run very deep within our company. And we wanted to really bring together for the first time this whole world of relational data and the world of search to really deliver a new breed of an analytics experience to really a much larger set of users. And so over the last 4 years, ThoughtSpot has built the world's first relational search engine from the ground up. And in the past year, Gartner has actually named us as a cool vendor in analytics, and most recently, this past February, we've also been selected as a vendor on the Gartner Magic Quadrant for BI and analytics as well. So on the right here, just a few proof points. We do have customers in all major industry verticals, such as Bed Bath & Beyond, Amway, Scotiabank, and more. So these are certainly use cases that we can share with you if you're interested as well. And even though, organizations have spent lots of dollars, billions of dollars on BI, we all know that data does remain largely inaccessible, and most organizations are really still struggling to get data in the hands of everyone, regular business people, in order for them to make those data-driven decisions. And the biggest challenge to analytics and most organizations' efforts around analytics today is that analytics still isn't easy enough. And most business users do depend on experts, as well as some of the more complicated tool sets that are available, which has ultimately resulted in a fairly large bottleneck to insights. And this is why with ThoughtSpot, we're really taking a different approach, a Google-like search-driven approach to analytics. And if you think about kind of the scale at which Google operates today, all of us use Google, and there are up to about 4 billion searches that are executed on Google today. And if you kind of look at ThoughtSpot and kind of the breadth of the knowledge workers, the number of workers, 850 million, and if each of those knowledge workers just wanted to ask 2 data questions a day, we really reach pretty vast amount of searches as well, up to probably half of the number of searches that Google does. And so this is really the opportunity that we see, and this is why we're really in this market. And rather than really focusing on a targeted set of experts, we really want to be able to expose and deliver data and insights at human scale to regular business people. Now, we all know how to use search, obviously, and applying search to enterprise analytics is kind of our mission. And so we do have expectations, as most end users do, for fast and easy access to data and insights, and none of those expectations have really changed. But it is a fairly interesting problem to solve, to apply the problem of search to go against rows and tables and data at scale. And as we are bringing together these two things, we always want to keep in mind kind of the different ends of the spectrum. First around human scale, to really make the experience extremely easy and intuitive, and to make sure that whatever data that you're searching across, that they'll be able to receive their responses and their answers in under a second. And one of the things that we are really sensitive to is the answers that we do get out of ThoughtSpot is the guiding principle is really around 100% accuracy and precision all the time. That's something that we are very confident about and very proud of with our search-driven approach. And as a guiding principle, as we continue to design new capabilities and make it even easier for users to interact with the platform and ask questions, we do want to make sure that all the answers are always 100% accurate. And then on the other side, around enterprise scale, there's obviously the requirements around the number of users and the data volumes into the terabytes of data, the complexity of the schemas themselves, coming from multiple different data sources, and how those relationships are actually going to be brought together for users to ask questions across a broader set of data sets, as well as enterprise level security and governance. So what we've built out is this relational search engine on this next generation analytics platform, being able to allow anyone to use search to find their answers on their data extremely fast, as well as to build reports and dashboards in seconds. A platform that can also be able to leverage parallel, massively parallel in-memory calculations that would scale to billions of rows, as well as the ability to perform analysis and provide answers across data sets coming from various different data sources, regardless of the complexity of the schemas that are involved. And ultimately, being able to provide that fast performance so that you don't have to rely on data experts or BI teams that would have to continuously build out data marts, cubes, create drill paths, etc. Provide a system and a platform that can leverage the machine to be able to determine those aspects for you. And then ultimately provide a centralized, managed governance and security with granular access all the way down to the column, row, and object level. And so what this means is, users can now ask as many questions as they want, and obviously, when users see a new visualization, a new answer, they're always going to ask that next question. And so, the real power is, you now have the capability to, continuously ask questions and get answers and get new visualizations and continuously build out a narrative of all of your data-related questions and answers without having to rely upon these data experts. And we're, putting a little bit of a humorous play here with the so-called data ninjas that are now kind of free to do a lot more strategic things involved with analytics. Okay? So before I get into the guts of the architecture and the stack, I did want to walk you through a brief demo. So I'm going to go ahead and switch the screens here. So this is ThoughtSpot as you log in to the instance. And what you will notice here is, as users log in, you'll typically land on a home page where you're greeted with a pin board. So pin board is our terminology, and I'll walk you through how a pin board is actually created. But this is similar to a dashboard that a lot of other analytic solutions actually do support as well. But what's really interesting about this pin board is that all of the visualizations that you see here and the answers across this entire data story and narrative is all of these are actually created through the power of search. So if you imagine me coming in as an operations manager for a restaurant chain, and I want to ask a new question here after having seen this particular set of dashboards. Maybe I want to ask a question about my customers by store region weekly. And as I type that out, I'm greeted with various different search suggestions, and I'm also provided with best fit visualizations in the form of a chart here. And I can always go back and ask more questions. So maybe I want to see this at more of a monthly type of time grain, and perhaps I want to filter this down to the last 2 years. So this experience is all search-driven, and as users are typing in this particular search query, the system basically is performing all of these number crunching in real time and providing you this best fit visualization. And as I type in through this search bar, I'm greeted with these search suggestions. So in this case, maybe I type in an additional keyword here that starts with GR. All of these suggestions from ThoughtSpot are based off of all of the different aspects of the data that it has already indexed. So whether it's field attribute names, whether it's field values, or whether it's additional objects within the system that other users or these particular data sets are actually provided on. And so the system actually leverages a fairly sophisticated machine learning algorithm that provides the users with kind of the optimal search suggestions based off of usage, as well as various different data characteristics as well. So in this case, I just want to go ahead and create a growth query, and I'm greeted again with a search result here that I may want to just pin on a brand new dashboard or a pin board. So I'm going to go ahead and create a new pin board and call this Top Bun Pin Board Webinar. I'm going to go ahead and add that. And again, as an operations manager, perhaps I have additional questions that I may want to ask. But one of the things that I may want to take a brief look at is what exactly is occurring as ThoughtSpot is actually taking this particular query. It's actually computing the aggregate across a number of customers in a data set across the dimensions of date and restaurant region, applying a filter on it, as well as linking information across various different fact and dimension tables in real time across the different relationships that it has inferred based on the structure of the data that it has actually brought in. And then it's also providing a growth calculation across all of that data. So users always have that transparency and to trust kind of what ThoughtSpot is actually performing under the covers as it's translating this particular search query into how it's actually performing the calculations and the operations to bring back that best fit visualization. Now, what's the data that the ThoughtSpot is actually searching across? Here in this data panel, you'll notice that we're actually running a query on this particular worksheet, a top bun worksheet. What this is an encapsulation of rows and various different base tables that have been brought together for the purpose of this particular use case. And I'll go through this in a little more detail and just a little bit further down in the presentation. But this provides kind of a singular, consistent set of metrics that users can query across as they're bringing together and kind of performing this data modeling effort for the purposes of search. And so in this particular worksheet, you'll see that there are various different attributes like customer name coming from a customer dimension table, orders coming from our fact table, store names coming from a store table. So all of these are different attributes that have been brought together as within this particular logical data model for the purposes of enabling these end users to ask questions for their use cases. So I can, as an end user, I can very easily ask additional questions here. Perhaps I want to understand sales by store state on the east, and again I'm greeted by search suggestions based on some of the more recent searches that have been performed, and I am provided with a geographical map, a geographical heat map, and again ThoughtSpot and its underlying BI and visualization server has provided me with this best fit visualization through its understanding of the underlying attributes and data within the data set. I can perform drill downs or drill acrosses, so I can very easily drill down to say store names within the New York region without having to pre-configure or predefine any types of drill path. Again, this is really the flexibility in what ThoughtSpot provides, so that users can bring in their data sets with full fidelity and enable the system to really help drive them across the various different types of questions that they want as they build out this narrative without having to spend the effort to predefine any of these drill paths. So once again here, maybe I want to add this particular visualization onto my narrative on my pinboard, and I can continue to ask the types of questions here. Perhaps in New York, I want to better understand why New York City is underperforming in terms of sales. So perhaps I want to ask some questions around throughput of my orders. So in these stores, so perhaps I want to ask orders per hour in the New York store by name and by transaction time. Perhaps I want to add another dimension here around employees to see if I'm appropriately staffed in these particular stores. And I do recognize that, hey, you know what, across lunchtime hours and dinner hours, there may be some further analysis that I may want to do to understand if my employees are appropriately staffed across these two different stores. So, these are a lot of the additional questions that users want to ask, especially if I'm an operations manager for this particular restaurant chain. And so this interaction here is extremely quick with this data set, and you can continuously ask questions and really build out that narrative until you get to that aha moment, that insight that you're actually looking for. And as a result, as you're building out this narrative, I've created a pinboard here for top bun, and this basically continues to build out the pinboard that can be more broadly shared across the team. One of the other things that I do want to show here is we do provide the capabilities to access the underlying data that has been cached and indexed within ThoughtSpot and expose these to more custom types of applications. In this case, I've come into a custom portal where we've actually accessed all of the data within ThoughtSpot and basically allowed the user, through the data APIs to create a custom visualization, an embedded experience, so to speak, of their data. All of the interactions still apply, so you can provide action filters, for example, and all of those still execute on the resulting business-to-business portal. If you wish to embed, a particular chart or visualization, that is feasible to do so as well. In this case, we are embedding a full visualization here that was crafted within ThoughtSpot, and all the interactivity, like if you wanted to drill down or apply filters, you can do that as well. Or, more recently, what we've actually started to do was to embed, a fully saved pinboard that was created within ThoughtSpot through the power of search, or even embed a full search-driven experience within your custom application as well. So again, various different options to enable end users to interact with their data, via various different methodologies, interactions. But that was really a fairly, on the surface walkthrough of the product. But what I did want to go through now is really take the time to walk you through kind of what's really going on under the hood, how we've actually built out this particular solution and its underlying architecture that supports it. So I'm going to go ahead and switch back to the slides here real quick. And so we're going to switch gears now and just take a little bit of a deeper dive into this next generation analytics architecture. And as we go through all of the different bits, again, feel free to ask questions if you have them and enter them onto the panel. And at a high level, this is ThoughtSpot's product architecture, which is purpose-built from the ground up for search, for ease of use, for enterprise governance. And so we'll take a peek under the hood of this architecture at the various different layers and the underlying components and how they interact with each other. And we'll go through them in this order. We'll start off with the relational search engine, the BI and visualization server, the in-memory relational cache, and its calculation engine, and then its distributed cluster manager, and then how we apply enterprise governance and all the related data connectors for our data access. So let's start with the relational search engine. And so, this relational search engine, this is really the core foundation of ThoughtSpot, and this is really the workhorse behind ThoughtSpot that provides a guided search experience that basically lets anyone analyze billions of records of data and get the results in seconds. And how we actually do this is in this search engine, we have a automatic search indexer that, as data is being brought in and cached within ThoughtSpot, it's recognizing and indexing related metadata around the data structure. It's related attribute names. It would infer relationships between various different data sets, from the source systems that the data actually came from, as well as the data values themselves. And as the index is actually executed, what it's doing is it's actually storing the data in a very efficient data structure, so that as users perform the search, it's basically leveraging this index, and the index lookups perform extremely fast and efficient. And on top of that, we've actually built out a machine learning-driven data ranking algorithm to provide the search suggestions that I had kind of walked you through in that short demo. And this basically makes it even simpler for end users to understand, what searches are being performed. What are the most relevant keywords for the searches, based on other searches that have already been performed, as well as the data characteristics. And the last thing here I did want to mention is also we have a search inspector. This is what provides that transparency to the query, so that you know exactly how your search results are actually computed, so that you can be confident that your search results are 100% accurate. And so before kind of going into more detail here, I did want to segue just briefly into what I call this search continuum. And if you kind of look at kind of the two ends of the spectrum, on one end is natural language query. Natural language query, obviously it takes a little bit more of a conversational approach for users to ask questions on their data, something like, how were my sales performing last year? Now, with full natural language query, however, is the experience oftentimes relies on guesswork. So the system needs to really determine what the user actually means when they're asking this question. So in this particular example, this is actually a fairly simplistic example, but just taking the question, how are my sales performing? What does sales really mean? Is it sales, or is it orders, or is it revenue? And if you're looking at sales performance, are you trying to ask a question on total sales, total amounts, or are you trying to ask a question on sales growth? So the system does have to perform some amount of interpretation of that question, and what this leads to is ultimately inaccurate results. And because of this more of a probabilistic approach, and because of this approach, natural language does actually work great because of its simplicity, but because of what it needs to do to transform this question into an underlying query, and a query that needs to be able to operate across rows and columns, and oftentimes have more complex relationships between various different data sets. Natural language query oftentimes just produces more accurate results, if it's operating on simpler and less data. And so there are a number of ways that users currently interact with various different tools around natural language, but oftentimes that interaction is largely limited to performing navigations or filtering on pre-created reports and dashboards. And so with relational search, which is ThoughtSpot's approach, we're actually taking a natural language-like approach. But again, as I mentioned, in the beginning of this webinar, is our guiding principle here is really around 100% accuracy with respect to the results. And so we do allow the user to really be that driver with respect to the types of questions that they want to ask. And what the system does is it really facilitates this interaction through its built-in algorithms to continuously suggest, the search terms, continuously suggest, search relevant keywords or prior, or more recent searches and such, so that it will allow the user to make that decision. And for lack of a better term, we actually call that disambiguate. So the user can actually make that decision and ask the question that the user really has in mind. And this approach is designed from the ground up to be able to interact with large volumes of data, billions of rows of data across fairly complex schemas, and at the same time provide sub-second responses to these questions. So here's an example of how ThoughtSpot actually performs its search indexing. And I'm taking an example here of a dimensional model, a sales fact table, along with various different dimensions for customers, books, authors, and publishers. And so as data is being cached in the system, what ThoughtSpot does is it automatically indexes what it recognizes as column attribute names along with inferred data types. It'll be able to recognize if certain data is coming in as text or date time information, or number data types, and then it'll also index column names, tables along with those column names. So all of this table structure information and the metadata around it, all of that is now cached and indexed. And it also indexes, what it has inferred as the relationships between these various different tables from its source systems. And so if there are predefined relationships in the source systems for these different tables, ThoughtSpot will infer those and bring those into the system and index those as well. So that as users perform their searches, ThoughtSpot will recognize, how to actually navigate and, automatically join across these different tables. And then, of course, there are those data values across all of these different tables, whether it's millions of rows or billions of rows. ThoughtSpot does index all of them, and these are all indexed into a data structure that makes the lookup as the search is performed to be extremely fast and efficient. And once it is indexed, once these base tables are indexed, users can automatically start and very immediately start searching. And as users perform searches on their data and ask questions on their data, you'll notice that we do provide these search suggestions as well as search relevancy through data rank. And this really leverages machine learning algorithms, as I have mentioned previously. And so these search suggestions do get better with use. And this particular illustration here doesn't fully depict the input and the output of the suggestions, but you can imagine if this were kind of a funnel taking in input from the metadata, the data values, answers, and pinboards or dashboards from ThoughtSpot, and taking all of those artifacts as inputs into this relational search engine. What ThoughtSpot will do, it's going to apply usage-based ranking as well as an understanding of the data characteristics, so that from a usage-based perspective, it understands who's asking the question, that user, the role, the group that user is in, the recent searches that has been performed, and if you kind of think of this as a set of concentric circles, the recent searches that the user has performed, the recent searches that the members of the groups have performed, and what recent searches that all users within the organizations have performed. It used this kind of a ranking and weighting to determine how to provide better search suggestions for the end users. And then from a data characteristics perspective, ThoughtSpot understands the underlying cardinality, the statistical distribution of the data, whether the data is an attribute or a measure, and along with its data types, as well as its recognition of relevant join paths as it creates these search suggestions. So again, it really takes this input and continuously feeds back into the engine to be able to make these search suggestions smarter for the end user. So the next part of the stack that I did want to walk through is the BI and visualization server. And what the BI visualization server does is it takes a search query from that search box and basically intelligently and dynamically converts that into a data query. So it understands what attributes that the search needs to go across, what grouping needs to be performed, what join paths need to be applied in real time dynamically, and any additional calculations that need to be applied on the result set. And so all of these calculations are performed on the fly, and the answers are returned, as you saw in the demo, as best fit visualizations. So if you have time series data, it'll be returned in a trend chart. If you have more dimensions on your questions, you may return with a bar chart that you may change into a pie chart. If you have geographical information or data that you've classified as geographical information, the system will intelligently bring back a geographical map to the end user. And along with that is also this notion of reusable logical data models, and we call that data worksheets. And data worksheets are basically an encapsulation of various underlying physical models for the purposes of kind of a shared business logic on combined data sets so that your user base has this consistent set of metrics across these worksheets for various different use cases. And so this is kind of an illustration of how worksheets actually work, and we actually call this data modeling for search. And so imagine there's various different underlying data sets that you want to bring together for the purposes of a particular use case. You may want to add all of these data sets into this worksheet. And as you bring in these data sets, you can also model and create a logical representation of the relevant attributes or columns from each of these different data sets that you want to be included in this worksheet, which is what the users are going to search on. As you are defining these different columns brought together through these different data sets, you can also apply various different calculations, and essentially these are column level transformations or calculations that you can persist within the worksheets. And then you also have relationships between those various different data sets. And these are relationships that have been either inferred as it recognizes from the different relationships from the underlying base tables from the source systems, or users can also define new relationships between these different data sets within the worksheets. Users can also define custom synonyms. So as ThoughtSpot recognizes various different search terms, ThoughtSpot actually has an underlying library of WordNet synonyms, but at the same time, users can also provide their own custom synonyms. So perhaps a particular search term like an amount, you may want to be able to search as revenue as well. So users have that flexibility and the ability to define these custom synonyms. And then, as you're working with these worksheets, you also define the access controls and the security on the relevant rows and columns on this worksheet. So once you've kind of defined the worksheet, for the purposes of your use cases and types of questions that you want to ask on this logical data model, you can obviously share this more broadly across your group. At the same time, because this is an encapsulation across a business view, for example, we do recommend you do create multiple worksheets, for the purposes of the different use cases that you do want to tackle. There are ways to have pre-created derived worksheets and include them within another worksheet if you wish to do so. But really, from a data modeling perspective, what you're actually doing here is creating this meta model, so to speak, for your end users to more easily search and ask the questions that they have on this model. So here's an example of how a search query is actually generated. And this is regardless of whether you're searching on the underlying physical tables or if you're searching across a worksheet, there really is no difference here. But you can imagine a user typing in sales, and the system would recognize that it's looking for an attribute sales from this fact table. And as the user continues to type in product and customer name, they'll recognize that now we want to perform this aggregate on the sales data for each of these dimensions for product and customer name. And you can also provide filters. In this case, we're using a filter on a particular customer name value, and so it applies a filter on that. And then it also, in this query generation, automatically links the sales and customer tables through a relationship, as well as the sales and product tables with another relationship. Now, a note here, I mentioned worksheets earlier. As you're creating this logical meta model within the worksheet, the underlying relationships of how the different entities are actually linked together, that's actually not materialized. And so what ThoughtSpot is actually doing is that at runtime, as a user is actually asking the question, ThoughtSpot is actually performing, those calculations, and it's actually, linking that information in real time to provide that result set. So the next part of the stack that we do want to go through is this in-memory calculation engine. And first thing to note here is that, as data is being cached within ThoughtSpot, we're basically caching everything in memory. And so as data is being accessed, through various different search queries, all of the processing and the calculations and whatever interactions or filters that need to be applied, that's all done through a massively parallel processing across this in-memory calculation engine to be able to provide end users that speed at scale as they're searching across billions of rows of data across multiple sources so that they can get their answers as quickly as they can. And because of this approach, we actually don't require, the types of, data manipulation efforts that a lot of organizations have to go through to actually tune the schema for the purposes of performance, like creating cubes or creating pre-aggregated data sets or summary tables, or breaking down the data sets into data marts for various different sub-business use cases. And so by doing so, our underlying in-memory calculation engine has the horsepower to crunch all of these numbers across billions of rows in seconds, and also maintain the source data fidelity so that users can very easily go across data sets without predefined drill paths. They can drill down on various different levels of grain if you want to query data by year or by month or by week or by time or minutes. All of that fidelity is actually maintained, and we allow ThoughtSpot to perform those calculations for you. We also provide data sharding and replication capabilities so that you do have the ability to further optimize how performance is actually handled within ThoughtSpot. So if you wanted to shard data across various different nodes, this does help create smaller indexes, so to speak, and this does help with respect to performance as well. Distributed Cluster Manager, this basically allows users or allows organizations to basically grow and extend their usage of ThoughtSpot as they go. ThoughtSpot is deployed pretty much as Lego blocks, and so if you have additional capacity that's required, you just kind of stack on additional nodes on top of the platform, and as you do so, we can basically scale out to any kind of data size without compromising your end user experience. And with this is also built-in fault tolerance. So any one of the nodes go down, processing continues on other nodes, so that as you're asking those questions, you constantly have access to the data to be able to get to your answers. The system also comes with proactive monitoring, so that it basically lowers that administration overhead because the system understands and collects information about how it's actually performing, and it also has phone home capabilities, back to ThoughtSpot to basically alert of any health issues with the system. So enterprise security and governance, this is obviously a fairly critical topic with respect to analytics and data. And so ThoughtSpot was designed with security and governance in mind. And ThoughtSpot does provide secure access at scale, so fine-grained permissions, regardless of number of users. We can support up to millions of users, as well as hundreds of thousands of security groups. Especially if you think about kind of the business-to-business use cases that you may have if you're interacting with partners or external users or customers. You're really going to be expanding your footprint for access to this data across really large sets of users, as well as large numbers of security groups. Not to mention the amount of data that you're going to be accessing as well. And so ThoughtSpot does provide the underlying infrastructure to support security and governance at scale. Also provides LDAP and SAML integration to tie into your enterprise directories, and also offer single sign-on support. And with this fine-grained permissions, and I'll speak to this in just a little bit on the next slide, but it's really object, table, row and column level security. And regardless of how you're interacting with the data and how users actually get to their answers, through transparency and through lineage and through auditability, we're able to provide users a means to trace back to how they actually got to their answers. So this is a brief illustration of how access control actually works. And so we do provide support for column level security, row level security, and object level security as well. So you can imagine, say, for different users and groups with column level security, as they're performing their searches, and all of the searches and the search suggestions, the access controls are applied on those as well. So, if this particular user group doesn't have access to, particular attributes, say store region, that would not be a particular query that they'll be able to ask. But in the case where, everyone has access to these different attributes, but now you actually have applied row level security, then you can ask that question across, sales and product and store region. But depending on what user group that you're actually in and what data values that you have access to, you may only see, in this case, perhaps, only the East region, data values, and in this case, only the West region data values. So that's how we provide that access control all the way down to, basically cell level within the data sets. And then with respect to data connectors, there's various different means to connect to underlying data sets and cache them within ThoughtSpot. We do provide JDBC, ODBC compliant connectors. There are also drivers that are compatible with existing ETL solutions. So if you already have existing ETL solutions, you can connect basically with ThoughtSpot as part of that ETL process, and cache your data within ThoughtSpot. We do also have connectors through our Data Connect solution to a lot of other data sources, whether they're relational data sources, they're on-premise or in the cloud. We have various different means to bring that data in and cache them within ThoughtSpot. The other means that we have here is a fast parallel loader, because we do understand that there's going to be a lot of data that you do want to cache within ThoughtSpot, and so we have a fast parallel loader that operates at bringing in data at 1 terabyte an hour, and to be able to allow users to ask those questions as soon as the data is brought in and indexed within ThoughtSpot. And just a side note here, I had actually listed this REST-based API here. This is actually REST-based APIs for you, as I showed in the demo, to create a custom product. Perhaps you want to apply custom visualizations on the data that you have brought into ThoughtSpot. You have the means to do that through our REST-based API. So just real quickly before we jump into our questions, wanted to walk you through that life of a query. And so as you see here, kind of going through this entire ThoughtSpot top to bottom product architecture, if you have your data here, the first thing that we're going to do is we're going to cache your data structure. So this is, your attributes and your tables, your metadata, your relationships that the ThoughtSpot actually infers from the underlying source systems. And we'll cache all of that within our in-memory relational cache and calculation engine and make those readily available for search as well. Then, with respect to the data, we're also going to bring that data in and cache that, and it's going to perform this indexing process, creating this, super efficient, data structure that allows end users to very quickly perform searches across these indexes that are created. So, as users start typing in a particular search, in this case starting with RE for revenue, the system now leveraging its machine learning algorithms to provide those search suggestions, based on, other users and their recent searches, as well as data characteristics, basically everything that it knows about, what searches have been performed on this data before. In this case, as users are asking a question on revenue, the relational search engine now sees that it's actually looking for a particular attribute in the orders table, and it transforms this underlying query within the BI and visualization server to perform this query on this orders table. We're not actually, translating it into a SQL query. This is really for illustration purposes. But once it's actually executed this query, it's now going to bring back a best fit visualization for the end user and ensuring that, all the relevant access controls are actually applied to the search results, as well as to all of the search suggestions that were actually provided. Now, let's say you now want to add an additional or ask another question and say you want to understand revenue by state. Again, the search suggestions provide, relevant search queries that you may be interested in, and you may just want to ask that first question, revenue state. And here it recognizes that it's going to bring, revenue from your orders table, as well as state from a dimension table, and it also finds a particular relationship between these two tables, and it's going to do this join in real time as it's executing this query, and then again surfacing back a bar chart that provides the relevant groupings across these various different state regions and the revenue facts across these different regions. So that was a fairly quick illustration of a life of a query. Hope that kind of brought together how all the relevant pieces within the ThoughtSpot architecture kind of interacts and operates together to support that search-driven experience for users to ask their questions on their data and get their answers in real time. So wanted to wrap up real quick before we go into our list of questions. Just to very quickly summarize, to get up and searching fast on ThoughtSpot, really there are just three things that you want to do. First off is connect your data, regardless whether this is on-premise data sets, cloud applications, or if you're operating on, if you have data within a data lake, or you're working across flat file extracts. Connect to your data source. You want to cache them within ThoughtSpot and let ThoughtSpot index that data. You don't need to worry about creating cubes or pre-aggregated summary tables. You don't have to tune your SQL. You don't have to create custom drill paths. But we do recommend creating worksheets so that you do have a logical encapsulation or a logical data model across all of your data. And then basically define your users and enable them to start searching and start asking questions on their data and leveraging that search experience to get to their insights, as well as create those reports and dashboards in a much more simpler approach, much more faster experience than they've traditionally been experiencing with the likes of more traditional business intelligence tools. So with that, we do have 5 minutes left. I did want to spend some time going through list of questions that have come in. So I do have BJ here. And so I believe he has been going in and answering a few of these questions, but there are a number of questions that are on this list here. So first question here is, go ahead.
Thanks, Andrew. So the first question here is around connectors to big data ecosystems. As Andrew mentioned, we have ODBC, JDBC-based connectivity, and we also have out-of-the-box connectors through our Data Connect feature to cloud systems and on-premise systems. And so if you have a Hadoop system in place, and if you have Hive, for example, we can connect to that using standard ODBC, JDBC connectivity. So the question around how do you integrate result sets from ThoughtSpot with other systems for further discovery? First of all, like I was saying earlier, through these connectors, you could mash up data from other systems that are outside of your enterprise data warehouse, for example, or on-premise databases. So you could bring that in and hook them up in the ThoughtSpot system and search across these data sets. But you could also export this data out of ThoughtSpot using a bunch of export options. There's the ability to download them into various formats that you can then use in your other systems, or you could use the API-based access to access the data programmatically and feed that or incorporate it into other systems. Question on worksheets. Can one worksheet process data from multiple sources like SQL Server and Oracle? Yes, the worksheet is a logical entity. The underlying data sources are immaterial. The worksheet simply represents a logical organization of entities in your system that is agnostic to where the data comes from. So yes, a worksheet can process data from multiple data sources. Question on mobile support. Our current application that we have is mobile responsive. We are in the process of coming up with a native mobile application, in the future. Let's see here. We've got a few more coming in here. The question around collaboration on pinboards. There is a feature that we are releasing shortly, which is the ability to comment on a pinboard. So you can have a threaded discussion on the side where people can collaborate on what they're seeing on the pinboard. Now, this is over and above what we already have in terms of our sharing capability and an ability to distribute pinboards in a scheduled fashion. Question around how much data can you store in the cache? We can scale to very large data volumes. Typically our base systems that we sell can load a terabyte of data, and then you scale as your data needs grow linearly. So if you have 10 terabytes, you can just scale by buying the appropriate number of nodes in the system. So that's one of the huge benefits of our system, where you can start small. For example, you can start at 250 gig type data volumes, and you can scale incrementally. So the incremental scale out and ability to go to tens, hundreds of terabytes is a powerful feature of the platform. Question around language support. We currently support German and Japanese and English, of course. We are committed to supporting more languages, and we have the infrastructure. And in due course, we will be adding more languages based on our customer needs. So can we deal with unstructured or semi-structured data? That's the question. We deal with semi-structured and structured data. We don't deal with unstructured data. Typically, if you have, say, unstructured data in a Hadoop environment, there is some curation of the data that has to happen before it can be meaningfully analyzed. Typically, that curation happens and it's made available through a Hive-like interface where that data is exposed, the curated data is exposed as tables and columns. And at that point, we can then consume that data. There is a question on hardware required to run ThoughtSpot. We can probably answer that question in more detail offline because it depends on your deployment options and depends on the data volumes you're trying to load and so on. And so we can answer that question offline. There was a question around metadata from source systems. How do we incorporate metadata from source systems into ThoughtSpot? So when we connect to these source systems to cache the data, we are also pulling in metadata about the tables and columns and relationships that exist in the system. Some of it is inherited. Some of it is also derived or inferred. If it's not available in the source system, we can infer some elements of the metadata in the ThoughtSpot system intelligently. And over and above that, users can go in and provide additional decoration of metadata, things like synonyms, things like naming of columns and additional relationships and so on. We also are in the process of working with integrations enterprise catalog systems. So if you have a centralized metadata repository, we can integrate with that.
Okay, so I think we have time for one more question, Vijay. So I think that the question is, can ThoughtSpot handle multiple fact tables?
Yeah, so that's a good one. We can do analysis that cuts across multiple fact tables. So we handle complex schemas like chasm traps and fan traps and so on. And we can do that at very large scales. So we have customers with billions of rows in fact tables, and we have scenarios where there are many different fact tables, and it's one of the powers of ThoughtSpot where you can analyze data that cuts across different silos. Typically in historically you may have these in different data marts. They may be different subject areas that cannot be combined together. We can support all of that. So within a particular worksheet, you could bring in as many fact tables that you need for your analysis, and we handle all the smart query generation to make sure that there is the correct counting and there's no double counting across many-to-many relationships and so on.
All right. Well, thank you, Vijay, for covering the questions that have been coming in along the course of the session. So I did want to thank everyone for your time today. I do realize it was quite a lot of content to go through, so hopefully you did have a chance to kind of experience, at least on the surface, what ThoughtSpot actually provides as a solution. I would also recommend visiting our website, and perhaps if you're interested to get a little bit of a deeper dive of a demo and schedule some time with one of our systems engineers as they can kind of walk you through that. With that, again, thank you everyone for your time today. Thank you, Vijay, for joining me as well for today's session, and hope to see you in a future